Alright, let's take a look at 9-5. We're going to be looking at a new type of base. But a lot of the rules that we've been doing with logarithms are going to remain the same. So it's important to remember through everything I say that that's new, that really we're going to be using a lot of the same tools, and things might look different, but in the big picture they'll be somewhat the same. Alright, so let's just get started right away. Look into where we're going. Right. Here in front of you, you have a chart of interest. Okay? Interest, how it's put into a bank account, and you can make money just by leaving your money with the bank over a period of time. And there's different ways to calculate interest, and usually it refers to how often it's calculated. So for instance, the first row here says if we use this formula, we can plug in different values for depending on how often the interest is calculated. So for instance, this formula here says that if we calculate interest for $1, we plug in $1, and after a year we calculate how much interest how much money you would have after leaving that dollar in the bank for 1 year. So it should come out to $2. But if we calculated that same dollars twice a year, it would come out to a little bit more. Come out to be $2.25. And if we calculated quarterly, 4 times a year, so you see the 4 is changing here, it comes out to a little bit more, $2.44. And so on and so forth. When we calculate more often, we seem to have more money. Okay? So even daily, 365 times a year, hourly, okay, every minute, every second. And what you notice is, look at this number. It's getting closer and closer to a number, and doesn't seem to get much further away. First it starts at $2, makes a big jump to $2.25, makes a big jump to $2.44, makes a little smaller jump to $2.61, then to $2.69, then to $2.71. And right after daily and hourly, you can see it really doesn't increase much more. Okay, this number that it's approaching to, that doesn't seem to change, 2.71828, okay, it's called the letter E. Okay, it's called the letter E, similar to pi. Okay, similar to pi, and as it seems to be a decimal that doesn't actually ever stop. Okay, it keeps on going forever. Okay, but this number seems to pop up a lot when we're calculating interest, and you can imagine, well, interest really has just about anything to do with money. So everything that involves money, every occupation, anything that has to do with financing really uses this number an awful lot. Okay, so it's a very useful number. Okay, so we're going to be concerned with calculating here, T, how long it takes to make a certain amount of money. Okay, now, since the variable is in the exponent, that means we have to use a logarithm in order to solve it. Okay, so that's where all this comes together, is that we want to know how long it takes to make a certain amount of money. Okay, I have to have a logarithm to solve that problem, and I have to know that my base, instead of being like a log base 10 or a log base 2, I'm going to have a log of base E. Okay, so that means a log of base, instead of 10 or 2, the base is actually this long decimal, 2.71828. Okay, so quite interesting. So we're going to be using this an awful lot. Okay, the nice thing is that since this is so widely used, this E, we don't have to type in log of base 2.71828. There's a special logarithm called the natural log, okay, and it's abbreviated LN. So instead of taking the log of both sides, like we have been, when we're dealing with the letter E, we can just do the natural log. Okay, and so it's, without it actually being written here, the base is E. So it's a nice substitution. We don't have to type in the 2.71828 every single time we're working with E. Instead, we can use this special natural log, and you'll see that on your calculator. So if I pull a calculator over here, and here's a TI-30, you can see that if I hit it once, I do get the natural log. Okay. And if I hit it twice, I can actually get the regular log. So I can work with both. Let's go ahead and take a look at some of these approximations. Okay, so just get to know your calculator. Make sure you know how to use it so you can type it in. So E, you can find that button on there. Looks like a little E. Okay, on mine it's going to be, let's see here. It's kind of right grouped together. You might notice if you know where your log button is, the E button is probably very close to it because they're used together. So E to the 5th. Okay. Make sure you get the correct decimals. Natural log of 7. So again, make sure you get the correct decimal. Okay. You might want to compare with the log of 7. And notice that they are different numbers, so they're not the same number. The log of 7, remember log without a base given is 10, right? And this is E, so this is 10 to what power equals 7. This is asking, basically, natural log is asking 2.71828 to what power equals 7. So you can see that's why they're different numbers. Alright, we do have some of the same identities. We can convert the same way. So whereas before we might have had, let's see here, let's say just making up a number, 8 to what power equals 6. We converted that to logarithmic form, saying, okay, the base is 8, the exponent is 6. I'm sorry, the exponent is x, the answer is 6. So we can say log of base 8 of 6 equals our exponent. So we can do the same thing with E. It just instead of having a number for a base, okay, E is our base, the letter. So we use natural log. Every time you're dealing with E, you always use the natural log. Now we have natural log. And again, the base is E, okay, of 6 equals x. And again, it's given that the natural log is always base E, so you probably won't see that written there. You'll just see natural log of 6 equals x. So with logarithms, we always had to put the base, the actual number, because this could be any number. This could be any base, right? So logarithms works for any base. Natural log is only E. So that's why when you're using natural log, you won't see the base written. It's automatically given that it's always E. Okay. And of course, we can go the other direction and convert it the other way. Okay. So if our answer is this exponent, we can convert the other direction. Let's see here. So this would be, again, base of E, right? So this is meaning E to the exponent is approximately what? Notice how we're using the approximate sign here because we're using these rounded decimals. We'll have the same identities we saw before. Remember, down here, the natural log is automatically base E. So this is asking basically E to what power equals E to the x. Okay, this is what it's asking. E to what power equals E to the x? Well, E, this must be an x for them to do the same, so the answer is x. And we see another identity very similar. Okay. We don't often use this one, but it also works the other direction. So let's look at a little solving. Okay. Again, the big thing to remember is that it's going to be similar, almost the same as all the logarithm problems. Right, if I had, instead of e, if I had 8, right, I'd do all the same steps that we did in the past section, and we'll use logarithm. But since it's base e, we'll use the natural log. So let's take a look. Again, we're trying to get the e by itself, like we would try to get the log by itself before. So let's subtract 2 on both sides. So we get e times, 3 times e to the x equals 2. Divide both sides by 3, so e to the x equals 2 over 3. And now in order to get the variable out of the exponent and down with the rest of everything else, that's where we can take the natural log of both sides. ln. And when we do that, since this is base e, this means this equals x. So we just have to type in what's the natural log of 2/3. Type that in. We're going to have, let's see here. And then 2 over 3. Type that in, and there you go. Now notice when I go from the next step, right, I'm going to use, well, actually I'm not going to use an equal sign at all. So there's a long decimal, right? Anytime you have a long decimal, that means it's rounded. So we're going to change that to approximation. So negative 0.4055. Okay. So we're going to do approximately negative 0.4055. Equals here before you punch in the calculator, and then after you punch it in, it's approximately. Alright, so let's practice just a few more. Again, my goal is to get this by itself. This is a little different from 1/8 just because there's a negative here. It's not going to change our work too much. So let's start it off the same way. Add that 9 to both sides. Negative 2 plus 9 is 7. Divide both sides by the 4. We have 7/4. Okay. Natural log of both sides. Okay. This time we have a negative x, right? Last time we just had a regular x, so our answer was x. This time we'll have a negative x come down here. Okay. Rewrite that, which means one more time we have to divide or multiply both sides by a negative. So this is going to end up equaling negative natural log of 7/4. Okay. Now notice that this whole problem, I leave this alone. I'm not trying to figure out what the decimal is until the very end. It might be tempting to punch this in the calculator and start seeing answers, but we want to resist that. That way we can just plug in the whole enchilada from the very beginning. So I'm going to plug in negative. Let's see, my negative button. Negative natural log of 7/4. And again, this is one of the big benefits to having a calculator like this. We can just plug it right in. So once again, the answer was negative 0.5596. There we go. Again, I used approximately at this stage. Let's take a look at just actually a little bit easier ones. These are more just the converting. Okay, so we got natural log on one side. Notice that there's no e's in here. So we can use this just to convert. to exponential form to solve. So here we go. E to the 7th power is going to equal 36. Remember, our answer is always the exponent, so the number by itself is always the exponent. So this is just saying e to the 7th power equals 3x. Divide both sides by 3. Then you can go ahead and approximate. And try not to do e to the 7th, get a decimal, and then divide by 3. Just type that whole thing in the calculator at once for the most accurate answer. So I'll have the e on top to the 7th power, and the bottom we'll just divide by 3. And there you go, 365.5444. 544. 365.5444. Okay, so just always read the directions, what decimal to round to. Okay, more of the same. Has a squared here, that's okay. Still the same idea. The base is e. Base is e. The exponent is the answer. 9 equals x squared. Okay, we can solve this. Take the square root of both sides. Now be careful here. When you take the square root of both sides, you do get a plus or a minus. And then we can approximate this. So we're going to have plus or minus some decimal equals x. Let's plug that in. Okay, square root of e to the 9th power. And that equals 90.0171. 90.0171. There you go. So both answers are okay. Sometimes the negatives we don't like, but if you plug a negative into this term, x squared, the negative squared will be positive, so we don't have to worry about domain. Natural log does have the same restrictions as log, that we cannot have the natural log of a -1 or something like that. Okay, if you try to pull that off, it will really quickly tell you impossible. Okay, so same thing with natural log or log of 0. Okay. It's impossible to take e to any power and get 0. E to the 0 power equals 1. So just to prove it, let's just plug in 0. Once again, impossible. Alright, so, but it's the fact that we're squaring the negative will make it a positive, and that's okay. Alright. Moving on, let's do some more practice. This is very similar now to what we've been working on. We're just dealing with the base e instead. So e to the -2. Actually, I did this backwards. Let's try this again. X minus 1 must be greater than e to the -2. Add 1 to both sides, so x must be greater than e to the -2 plus 1. And you can type that in the calculator to get your answer. And one more. Base e, so 3x plus 2 must be less than e to the 5. Go ahead and do some solving here. 3x must be less than e to the 5th minus 2. Divide both sides by 3. X must be less than e to the 5 minus 2 all over 3. Okay. And we can type that in. Okay, here we go. So we have e to the 5 minus minus 2 all over 3. Right, about 48.8, 80, 44. 8, 80, 44. All right. One more thing we have to be careful of. Does this mean that every answer below 48.8044 is an answer? So, yeah, 24, sure. 12, yeah. But remember, we cannot have 0 or negative here. So for sure, this has to be bigger than 0 at any time. So remember, for our domain issues, just to keep 3x plus 2, to keep it bigger than 0. Has to be bigger, not greater than equal to, but strictly greater than. Okay, so let's check this out. And then if we divide both sides by 3, so that we know any number has to be bigger than negative 2/3 no matter what, because this has to be bigger than 0. Okay. So it can be less than 48, but it has to be bigger than negative. Okay. And this is the way we write it. Yeah. 48.8044. We are decimal. You might ask me, well, wait a minute. I thought we couldn't have negatives. Okay, so think about it. If you plug in this number, that's when you get 0. So it's not the number, the answer can't be negative. It's when you plug it in, it can't be negative. So anything bigger than negative 2/3, like negative 1/3, you plug in negative 1/3 here, you get negative 1 plus 2, which is positive 1, so that's okay. So it's okay to plug in negatives as long as you don't get a negative in the answer. It was the same case back here, where it was okay that we had a negative 90, because when we plugged in negative 90, we squared it, and this was now positive. So it's all about when you plug it in, is it positive or not if the number you're plugging in is negative. All right, hopefully that helps, and just try to remember all this is very similar to what we've already done. And if it helps, you can change the natural logs to regular logs and pretend instead of e it's a different number, and all the steps will be identical. Okay, nothing's going to be different. All right, and always come in for help if you need it, before school, after school, and on Saturdays.